Adventures of Willow, Density and Buoyancy. Density is the amount of matter in a certain space. The equation is density equals mass divided by volume. The units are grams per centimeters cubed or grams per milliliter. Density is a way to identify a substance. It's kind of like a fingerprint. Mass and volume will vary, but the density doesn't ever change. For example, the density of water will always be 1. The cube on the right has more stuff or dots in it compared to the one on the left in a certain space. So the one on the right is more dense. And here, Willow floats in the water because she is less than 1 gram per milliliter. Forces. A force is simply a push or pull on an object. Size and direction are very important when you're talking about forces. Often, more than one force acts on an object. Therefore, the result is a combination of the different forces. Otherwise, we call this the net force. When Willow tugs on a toy, she is providing a force. Now, if I were to tug back on the same toy but in the opposite direction, I have a force. But to get the net force, you would have to find the difference between our forces. Forces are shown with arrows. The larger forces will have a larger or thicker arrow compared to smaller forces. Buoyancy or buoyant force acts in the opposite direction of gravity. This is what makes you feel lighter when you are in water. If weight, which is due to gravity of an object, is greater than the buoyant force, the object will sink. But if the weight of an object is equal or less than the buoyant force, the object will float. Notice the picture in the right-hand corner. Willow is able to swim or float because her weight is less than her buoyant force. The buoyant force is the thing that keeps her floating. Pressure. Pressure, P, is the force, F, divided by the unit area, A. For example, the pressure of a block resting on a table is the weight, force, of the block divided by the area of contact with the table. Density affects pressure. A high heel has a lot of stuff or mass packed into a small surface area, so it's going to have more pressure at the point of contact. Compared to a dog stepping on your foot, the area is bigger, so it's less pressure. It's not all at one point.